stacks the resulting 4 pieces and cuts them in half, and so on. You investigated the pattern in the number of ballots created by each cup. In this problem, you will look at the pattern in the areas of the ballots.
Okay, so here we go. Today, you're going to focus on, your task is to complete A through E. When we're looking at these ballots, what happens when now we start off with an area of 64 of these squares, and we're doing the same motion as before these ballots. We're cutting this in half and continuing this pattern. I want you to think about what happens to the numbers as you complete this table. We're going to be graphing our data to kind of get a sense of what this graph is going to look like. And I want you to think about this. What if this constant multiplier, what if it's a fraction or a decimal? How is this going to affect what's happening to our data in the table? Yes, Love?
If it's a fraction or decimal, it would be kind of the same thing as dividing by a whole number. For example, if you multiply by 1/2, it's the same as dividing.
Okay. So with that in mind, we're going to look at this. What happens when we record this in a table? What happens once we graph this? And then eventually you guys are going to come up with this fabulous equation. Any questions before you start? As you're working with your group, I want you guys to definitely talk about things you're noticing, observations, possibly make some connections of things, some similarities between investigation 1, which was a growing pattern, to investigation 4, which is a decaying pattern, or it's decreasing. Make connections about how are these things similar, how are these things different. This is what I want to hear when your groups are working and discussing. Questions before we start? All right, get started. You can. Oh, absolutely.
Yeah. So at the top, 32.
So you may have the inverse. You can go backward.
So instead of
Going backwards by
increasing,
half.
it's decreasing.
I'm going to divide by 2. What's happening with math?
And the growth factor would be 1/2.
Isn't it the same thing we did in the other data? That we should have.
Giselle, how did you just figure out 1/2?
Because dividing by 2 is the same. Dividing by 2 is the same as multiplying by 1/2.
Thank you.
Right? So, even though his pattern, it looks right, you know.
BJ, I'm looking over your shoulder. Is that okay?
Yeah.
So 16 divided by 2 is 8.
Thank you.
It's 2. Isn't it 1?
Yeah, and then it's 1/2. I mean half. And then it's 10. So it's 0.25. I'm back to 0.125. And it's 0.0625. It could decay. So it's like kind of like decreasing by a growth factor of 2.
So we could say that it is dividing by 2.
Can I look at the table you've written so far? Thank you.
So B is divided by 2.
Figure that out.
For the area after
We know that it's dividing by 2.
okay, so it's
That we can use it as like kind of
How about next?
Yeah, like the pattern change. So we'll change it.
I see that like 0.5.
But doesn't the number have to do with
Wouldn't that be? Because the previous number is divided. It's dividing by 2.
But doesn't like it has to do with number of cuts, like area, not just straight, just the area.
Okay.
Do you think this is
So it's linear? Huh? It's not linear either. It's not inverse. It's a different kind of pattern.
Doesn't it have a growth spike?
Well, it's not growing by different. It's not growing.
But it could be A.
It's actually different.
That's why. It growth spike can also mean a decrease. It's an exact math to make that. Oh, it's like growing by decreasing.
Isn't it like subtracting like
How do you look at the question?
the previous or like
Yeah, it is.
the next answer?
But we have to
minus the
find an
previous?
equation that includes the number of cuts. It says write an equation for area A of valid after any cut n. So how does 0 relate to 64 and how does 1 relate to 32? And all the other numbers.
Divided by two variables in the equation. A and have to make the equation exponential.
How do you know that it's exponential?
Because it has a growth factor of a half.
Say it again.
64 times 1/2 to the power of n equals 8.
How did you get that equation?
Because the y intercept is 64, because that's the initial start. And then since we know it's increasing by 1/2, then you multiply the number of cuts by 1/2.
So what happens if you take this and you make it 7?
Nicely done.
Does everyone have graph paper?
Yeah.
I'll cut it up for all of us. Thanks.
Wait, but I didn't get the growth factor.
The area of the balance increase by 1.
Oh, yeah. But the n decreases by 2 or increases by 1.
What do you have now? Oh, we have half, right? So this is
Wait, I think I got it. I think I got the equation. I got the equation. It's divided by.
much of it.
That's what I have. Yeah, we got it. Well, thank you.
So you said that we had, you said we had, it's less than half, or it's less than the full square, and you said it's half the half. What do you think? That's mean if you have half of the half. I believe this is where, this is your half, right? And now you have half the half. This was your, was your half. And now you have half the half. So what would you call it?
Algo así, ¿no?
Sure. Yeah, I can definitely see that your pattern's decreasing. Could this continue beyond 10 cuts? Will we keep on going? It'll stop at some point.
Most of them are multiples of 4.
You guys are lucky you got what else?
Think about the scale.
How many cuts do you think that
There's also fractions.
It's gonna start from the top. So you'll start with 64 and then
And would be
Okay, so it's basically the point where you can write a name on your ballot. Okay.
What are we going up by? 4. What does that have to do with
4s?
4? That's too much. No, it's 16. I said 5. 5 will only
16 spaces.
yeah.
So they're just not cutting.
Yeah.
All 5 then?
Yeah.